Alright, so for everyone quieting in now. So Tom, Jess, Alan, Tim. Tom, Harry. Okay, so we're starting chapter 2 today. Tomorrow you've got a quiz covering all of chapter 1. And we are really starting to pick up the pace now. So I will check where you're up to later today. So I would suggest that you write down everything that I write down. And we will do a couple of questions from the work program today as well. Your normal book. This doesn't need to go in your bound reference. Yes, you want the aircon. Yep. Okay, settling down. Still waiting. Okay. So if you're new to my class and you weren't in general maths last year, there's some new terminology that we're introducing today. Those two terms are the explanatory variable and the response variable. So those are terms that you need to know. And the reason is because we're going to try to predict things. So now I think I asked this question to my class last year. When you do science, do you learn the terms independent and dependent variable? Okay. So that's good news. The explanatory variable is just another name for the independent variable, and the response variable is just another name for the dependent variable. Now, at the moment, these are just words. So in this class, we use the terms explanatory and response. And the idea is we try to use one variable to predict the other one. We're going to try to use one variable to predict changes in the other. So, for example, I might notice that when the weather is hotter, I might have a better chance of selling ice cream. So I might ask the question, are ice cream sales associated with the temperature of the day? In that instance, which one do you think would be the explanatory variable? Which one is trying to do the explaining? We're trying to use the weather to explain ice cream sales. Please notice that I can't go the other way. I can't really use ice cream sales. Well, I guess you could ice cream sales to predict the weather, but somehow that seems a bit backwards. All right. So those of you who are doing science, which one are we changing? Which one's the control? Which one's the experimental group? Is it the explanatory or response variable? Explanatory. Okay. So if you're ever in doubt, and so if I have a science background. So I'm always thinking, if I were doing an experiment, which variable am I changing? The one that I'm changing is the explanatory variable. Okay? In general maths, one of the key words is predict, particularly when we get to numerical variables later this term. All right, so we're actually going to do a whole question now from 2A, and we're just going to discuss it together as a class, and then we can tick it off. All right. So let's say I had a bunch of fish. They're all different colors, and I was interested in using the color to predict how toxic the fish is. Which one's going to be the explanatory variable? Color. Okay, the color is the explanatory variable, and the toxicity is the response variable. All right, so we're knocking off question 2 from 2A right now. Okay. Um, next one. The next one is trying to investigate whether different types of diets will impact the amount of weight I lose. So does it matter? Which one is going to be the explanatory variable here? Which one am I changing? The diet. Okay, I'm changing I'm changing diets, and depending on the diet, I'm interested in observing whether the amount of weight I lose is going to change. So because I'm observing, you're really thinking of the response variable there. So usually you change the explanatory variable and you observe changes in the response variable. Okay. As a car gets older, its price changes. Go up or down. It goes down very quickly. So in this, huh? Oh, like those rare cars. Okay. So guys, listening. Hi. So in this instance, it's not clear from the wording of the question whether I am using age to predict price or whether I'm using price to predict age. But usually, there's going to be one interpretation that's more natural. And I kind of gave it away already. Age to predict price. So if I use age to predict price, I refer back to this first sentence here. You use the explanatory variable to predict the response variable. So age is going to be the EV, and price is going to be the RV. You will be asked to do this on the exam, identify the explanatory and response variable. I will also ask this on the SAC. So just make sure that you get it around the right way. Because people do get it wrong, unfortunately. All right, how are we feeling about this? Is this all right? Yeah. Okay, definitely easier than last week's lesson on the normal distribution. Okay, so we'll do a couple more. Type of fuel versus cost if you're trying to heat up your home. Yep. All right. And last one, house price and location. Yep. What's that saying? There are 3 things in real estate: location, location, location. Something like that. All right, year 12, settling down. Cooper, Jazz, Harry. All right, so we've done question 2. Question 1 and 3 are very similar, but I'll leave that to do in your own time. You're also asked in those questions to identify whether the variables are categorical or numerical. So if you've forgotten that, that will be good revision for you. And that's 2A covered. So we're going to go straight on to the next one. So leave a couple of pages in your book blank. Maybe just 1 page will be enough. Okay, you don't need to get this down. These are just some pictures. Don't worry. I'm just going to talk about it. Okay. All right. So, Kaylin, Harry, Charlotte, Janice. If I have to keep stopping every time, it's going to be a long year. So, do you remember our very first lesson last year? Seems like a long time ago now. Do you remember what we started off with? Numerical and categorical data. Why do you think? Well, it's a rhetorical question. So you might wonder, why would we spend the time to try to classify data as either numerical or categorical? We've just, huh? Okay. Yeah, we can do things because it's fun. That's a good reason. So another good reason why you might choose to classify data is because we've just spent some time trying to investigate relationships to make predictions between those two variables. And so, depending on the type of data you have, you're going to have different representations. So, the first case that we're going to look at today is where both the EV and the RV are categorical. Okay, so they're not numerical variables. Tomorrow, we're going to look at categorical versus numerical. And then for the next term, literally all of term one, after tomorrow, will be the case of two numerical variables. We're going to spend a long time on this. And if you were in my class last year, you might recognize this picture. If I have a bunch of data, I might want to try to predict one of the variables by fitting a straight line to the data. The question is, how do I choose the gradient and the intercept for this line? That's a big question that we're going to ask in this class. But that's coming later. So just for today, we're going to look at categorical versus categorical. So the way that we represent this data is what's called a two-way frequency table and a segmented bar chart. So when you come across these terms in your textbook and the exam, this is what I'm talking about. So why don't you just have a quick look at that table there. I've just made up those numbers. That's our school. Do you notice? Okay, what do you notice? Okay, so in year 12 there are less students. Yep. All right. Now, a question that I might ask is there an association between the type of art subject chosen and the year level? So have a look at the year 11 group. Is there a subject that's more popular? No. They're 50-50, right? What happens in the year 12 group? Studio art is slightly more popular. That's this group. So everything that we're going to do today is going to be asking, are these two bars different or are these two groups different? Now, what's one of the challenges here? The numbers are different. So is there a way that you can think of that we can use to make these two groups comparable? Slightly tricky question. Yeah, actually, yeah. So if I change this to 40, 18, and 22, yeah, okay, I like it. What if it wasn't 20? What if it was a different number? You could? Yep. Yeah. Nice. Yep. And okay, great. No, I like it. So, and the other way that we can do it, which I will now go through, is to just convert everything to a percentage for each group. Okay. All right. So, this has gone a lot faster than I thought, which is good. because this is the last example, and then you have the rest of the time to work. Okay, so this is exercise 2B, question 4. Again, taking this off your work program because it's huge. So we've been given some data, male and female, and then whether they're left-handed or right-handed. And so I guess the question we're trying to answer here is there an association between the two variables? For part A, we're asked, which one's the response variable? Yes, I think you should write this. Yeah, so create some space for 2B in your workbook, and then you'll have this question done. Yes, Tom.
It's okay. No, it's alright.
It's all right?
I'll just let you explain it and then I'll see if I was anything.
Okay. I haven't written down all the information, so I'll just read it out for you. Okay? The table opposite was constructed from data collected to see if handedness, that is left or right, was associated with gender, that is male or female. That's it. So I think this is not such a clear question. Which one do you think you're predicting here?
Gender. So if your gender has an effect on your so handedness would be response. Yeah. And then why are you looking at details?
Yeah, no. So I think this is not so easy. So let me tell you what I think, and then you tell me whether you agree or not. And I'm happy for you to disagree. So I think what this question is asking is, are there differences between males and females?
No, we're all equal.
Okay. So let's use some data to investigate that. Okay? So for example, is the proportion of left-handers and right-handers the same, regardless of whether you're male or female? I think that's the way the question's being posed. But does anyone think it's the other way? So if someone comes to me and says, I'm left-handed, am I going to try to predict whether they're male or female?
Yes. Oh, it's a trick question. So nothing's right.
Yeah. What's up, Tim?
You can't really get a right answer if there don't have an equal number of males and females.
Unless you convert to a percentage.
Can you? No, it's okay.
Okay, so I don't want to dwell on this for too long. I'm going to propose that that gender is the explanatory variable and handedness is the response variable. Huh?
No,
You tell me.
Wait, so we're right.
EB? Okay. 4. Is the EV. Okay, so this is right? Okay. Okay. I'll just warn you guys, sometimes the back of the book can be wrong. Life doesn't come to us with answers at the back of the book.
Damn it, Harry.
That's what schools taught us as well.
Well, welcome to the real world. Yes.
Can you even find the RV because there's not the same amount of people in the male and the female?
Great. So this question is really nice because they actually set it up for us. So you're right, Tom. If I do a total column here,
That's a great line.
no, it wasn't, and you know it. Okay. All right. So if I total up the male and female groups, you'll see. I can spell. The male group is larger. So I can't compare them just using these numbers. So before we had 20 and 40, right, we could just double the 20. we're going to do something similar to that. This time we're going to convert these to percentages.
Oh.
All right, so I want 22 as a percentage of 244.
9%.
That seems too low. Wait, 9.7 did you say?
Do it in your head.
Do you all know how to, do you all know what this means?
Yeah.
Alright, okay, so I need to check this before you all sit your exam because this was an issue at the end of the year last year. A lot of people couldn't do percentages.
What is that?
I was running an outfit.
Okay, if I know that this cell here, male and left, is 9%, do I need to do the calculation again for the right hand?
Yes. No. Yes, you do. We can do it from the total. No.
They add up to 100%.
No, that's it. Oh, wait. It's just not.
Okay?
Silly boy.
It's, sorry, 91.
Yeah,
Yeah.
what? I was right.
I gotta roll.
Okay? So just remember percentages add up to 100 and we've only got two groups here. So if you calculate one, just take 100 minus the other one. Alright. Let's go again. 16 divided by 163 times 100%. Thank you. I think we're having too good of a time here, guys. Okay, have a look at the table that I've constructed down here. Alright, it's in the square, okay? The rectangle. Alright, we started off with raw counts of data. Raw counts of data in two groups of a different size. Now I've made them, it's as though they were out of 100, right? So if I had 100 males and 100 females, then something looks wrong. Yeah. Thank you. I am having a great day, just like you guys. All right.
How does it feel to be having breakdowns?
Okay, teachable moment. I looked at that table and I could immediately see something was wrong. What was wrong about the table? The column should add up to 100%. Okay? Alright, so that looks better now. Okay, so guys, this is the important part here. We've got the percentages, we've got two groups that are now comparable. How do we decide whether there is an association between the two variables? I haven't told you, by the way, so what do you think? So Tom, you were saying you don't think there's an association. Now, based on the data, why do you think that?
Well, the data is very close together, very similar. So I don't think that there's enough, it's negligent, the amount of difference between
Okay, so I want you all to listen very carefully to this. If the percentages are very similar between each column's group, then there's no association. But if the percentages were very, very different, for example, 50-50 for the female group, then there'd be an obvious difference there. Okay? So if the numbers are similar, then there's no association. If the numbers are very different, then there is an association. You can tell the groups apart by looking at them. Okay? So, no, there is no association.
no handedness.
Because, for example, 9% of males are left-handed. This is very similar
That means 91% of men. What? No, I'm part of the 9%.
So notice here, I'm actually using the data. So you would get 1 mark for your answer, yes or no, and you would get 1 mark for quoting an appropriate statistic, comparing the groups. So my argument is 9% and 9.8% are very similar. Okay? And that's how you get the extra mark. All right? Now, you might think, what if it was 11%? Is that different enough? Or 15%? We don't need to worry about that in this course. So if you do statistics at uni, you will learn something called the chi-square test, but we don't do that in this course. So just look for whether the numbers are similar. It'll be very clear. Okay? That's it. Any questions? Yes. Yes. You should come to class prepared. Jason. Yeah. All right. Please make a start on 2A and 2B. I will be checking your homework as well. So have it ready.